Good afternoon, everyone. Let us start.
Good afternoon, sir.
Remember, we have been learning Chapter 3, Interior of the Earth. Last time we discussed about causes of earthquakes, then different types of earthquake waves, how do earthquake waves move. Today we shall start with a discussion on types of earthquakes. Now I will present types of earthquakes. Actually, we have 5 types of earthquakes. Now let us read. The most common ones are the tectonic earthquakes. Okay, the most common type of earthquake is tectonic earthquakes, and these are generated due to sliding of rocks along a fault plane. So we have to recall the faulting process. Okay, these are the different layers or the formations. So this is one formation, that means a layer which was formed in a particular geologic time. This is another one. Okay, and see, within the rocks in the earth interior we have tensional forces. Okay, because of the tensional forces here at this particular point there may be a faulting process. Okay, here it may be slided like this. Okay, see here. It is here, the second one is here, and the third one is here. And see, so this is the first layer. The first layer is coming here, subsided here, and second one is coming here, and so on. Okay, so this is known as faulting, and because of this sliding of the rocks, okay, along this fault line energy is released, and because of that sacking and trembling of the earth surface is occurred, and this is known as tectonic earthquake. Okay, such type of earthquake occurred by sliding of rocks along a fault plane is known as tectonic earthquake. Okay, see, we have these are the different types of sliding, okay, of the rocks, different types of faulting process. See here, this is the one which I have drawn earlier, normal faulting process. See here, in this case the left side is slided. Okay, and it may be sliding in this way. Okay, see, this one towards us, another away from us, and in the other case here this portion may be slided upwards. Okay, see here, here this is the first one, and another one may be, say, sliding in this way. Okay, so in the other case, so this section may be slided upwards. Okay, see, in this case this section is uplifted. In this case also earthquake is occurred in this sliding of the rocks, okay, against each other. In this case also earthquake is occurred. So such type of earthquake is known as tectonic earthquake. Any question from your side about tectonic earthquake? Okay, a tectonic earthquake is the earthquake which is caused by faulting process. Okay, which is caused by faulting process. If you don't have any question, so let me proceed. So the next type of earthquake is known as volcanic earthquake. Okay, so this is a special class of tectonic earthquake, and whenever we have a volcanic eruption, okay, at the time of eruption there will be shaking and trembling of the this earth surface. So for example, this is a volcano, a volcanic cone or mountain, and from the mantle magma may force to rise upwards, and suddenly this mouth may be exploded. Okay, and at the time of explosion, say there may be shaking and trembling of the earth surface, and the earthquake which is caused by the eruption of a volcano is known as volcanic earthquake. Okay, then so the third type of earthquake is collapse earthquake. Okay, so in the areas of this intense mining activity, sometimes the roofs of underground mine collapse, causing minor tremors. These are called collapse earthquakes. So collapse earthquakes occur in the mining areas. Okay, see, let us suppose this is a mining area. Okay, and here mining activity is going on here in the earth interior, and here we are digging a shaft tunnel, and people are working here. Okay, so miners are working here, and sometimes this roof of the mining area may be collapsed. Okay, so this roof of the mining area may be collapsed here, and when this roof is collapsed, there may be tremor, there may be shaking of the earth surface, and that is known as collapse earthquake. Okay, the earthquake which is caused by collapse of the these roofs of underground mines is known as collapse earthquake. So it is occurred only in the mining areas where the mining activity is of underground type. Okay, and next we have this another type of earthquake known as explosion earthquake. So ground shaking may also occur due to the explosion of chemical or nuclear devices. Such tremors are called explosion earthquakes. When a very powerful bomb, okay, maybe a nuclear bomb or this a nitrogen bomb or atomic bomb is exploded, okay, or TNT bomb is exploded, then there may be tremor on the surface of the earth, and that is called explosion earthquake. Sometimes you may experience this one also when a very powerful bomb is exploded nearby us, then we feel the tremor. Okay, we feel the shaking of the earth, and that is known as explosion earthquake. And next we have the last type of earthquake, that is the reservoir induced earthquakes. See, the earthquakes that occur in the areas of large reservoirs are referred to as reservoir induced earthquakes. So these occur mainly in the dam sites. Okay, see here, let me open another page. See here, let us suppose this is a dam site. Okay, here this is the dam, and here because of this dam it becomes a reservoir, and you know say the weight of water is also very great, so this is a big reservoir. And if this underlying rock is weak, okay, if the underlying rocks here is weak because of the weight of the water from above, okay, there may be the subsidence here. Let me repeat, if the underlying rocks here just below the reservoir is weak, okay, it cannot support, it may not be able to support the weight of the water, volume of water, and that is why this section may be collapsed downward, subsided, okay, downwards. And at the time there may be this tremor, there may be earthquake, and such type of earthquake is known as reservoir induced earthquakes. So these are the 5 main types of earthquakes. Do you have questions regarding the types of earthquakes? Anybody? Do you have any question regarding the types of earthquakes? Are you clear?
Yes, sir.
Okay. Still you're seeing my screen, right? So let us proceed. Next we have these measuring earthquakes. Okay, the strength, the magnitude of earthquake, measurement of this magnitude or intensity of earthquake. Now let us read. Earthquake events. Earthquake events are scaled either according to magnitude or intensity of the shock. Okay, earthquake strength may be scaled either according to magnitude or the intensity of the shock, that is the tremor. The magnitude scale is known as Richter scale. Okay, the magnitude scale is known as Richter scale as it was propounded by Charles F. Richter in the year 1935. He was an American seismologist. Okay, and the magnitude relates to the release of to the energy released during the earthquake. Okay, magnitude scale is related to the energy released at the time of the earthquake, and the magnitude is expressed in numbers 0 to 10. Okay, the smallest value is 0 and the maximum value, the highest value is 10. In this case, in the Richter scale, the smallest 0 and the maximum, the highest value is 10. Then what do you mean by this earthquake magnitude? Okay, so earthquake magnitude is a measure of the size or amplitude of the seismic waves, of the earthquake waves generated by an earthquake. Okay, this and recorded by seismograph. What do you mean by this amplitude? Let me tell you. Okay, see here, let us say this is the direction of propagation, and let us suppose this is the wave, and say this is known as wavelength. Okay, the distance between the two crests is known as wavelength. Okay, what did I say? This is crest, and this is another crest, and here the distance between the two crests is known as this wavelength. And here, and see here, Yeah, let us draw a line. Sorry. Okay, and see here, this is known as wave height. Okay, and half of the wave height is known as amplitude. See here, amplitude means this one, half of the wave height. So this is known as amplitude, and this is known as wave height. Okay, and this is what? This is known as amplitude. This is known as amplitude. Okay, let me repeat. Earthquake magnitude is a measure of the size or amplitude. Okay, earthquake magnitude refers to the size or amplitude of the seismic wave. So what is amplitude? Amplitude is the half of the wave height. Okay, see here, half of the wave height is known as amplitude. And so this is about Richter scale. And see here, somebody says that, okay, see here, say Richter scale, say 1 for example. When the Richter scale of the earthquake is 1, so we may not felt, okay, we may not feel the shaking of the earth. Or say at 3 also, okay, at 3 also we may not feel the shaking of the earth. But when it is increased to then 4, we may feel it. See here, from 3 to 4 we have a difference of 1. Okay, we have a difference of 1. So here in case of Richter scale, an increase of 1 magnitude, okay, an increase of 1 magnitude corresponds to an increase of these 10 folds, okay, in the wave amplitude. An increase of 1 magnitude increase to 10 folds, okay, is equal to 10 folds in the wave amplitude. And for the release of energy, okay, an increase of 1 magnitude equals to an increase of 1 magnitude, okay, is equal to an increase of 30 folds. 30 folds in the amount of energy released. That means the increase in the magnitude scale is not linear. Okay, the increase in the magnitude that is Richter scale is logarithmic. Okay, so an increase of 1 magnitude means that, okay, means that there is an increase of 10 folds in the wave amplitude, or there is an increase of 30 folds in the case of release of energy. So that means an increase of 1 magnitude is very great. Okay, that means from 3 to 4 you will find a lot of destruction, then 4 to 5 again 30 times, then again 5 to 6 means 30 times of 5. 6 magnitude means 30 times of 5. Okay, so this is about this magnitude scale. Next we have this intensity scale. Intensity scale is named after Mercalli. Okay, Mercalli, so he was an Italian seismologist, and see the intensity scale, it takes into account the visible damage caused by the event. So intensity scale is measured, okay, after seeing the visible damage. And in case of magnitude scale, it is based on the energy release. Okay, in case of magnitude scale, it is measured based on the energy release at the earthquake at the focus. And in case of intensity scale, it is measured after examining the visible damage. And the range of the intensity scale is between 1 and 12, that is from 1 to 12. Okay, so for example, a Mercalli scale of 1 means that no felt. Okay, not felt, that means we do not feel the tremor. Human beings do not feel the tremor. Okay, scale 1. Then scale 2, felt by the this person's at rest. When you are taking rest, when you are sitting somewhere, and at that time if earthquake is occurred and you are feeling it, okay, a little, that is Mercalli scale 2. And then the maximum one is 12. So when the Mercalli scale is 12, then large rock masses are displaced, then objects are thrown into the air. Okay, from the ground, objects may be thrown into the air. So that is Mercalli scale 12. So in this way, the magnitude or the intensity of the earthquake waves are measured. Any question from your side? Boys and girls, any question from your side?
No, sir.
No, no, sir.
No, sir.
Okay, then let me proceed. Next we have effects of earthquakes. And see, earthquake is a natural hazard, as you know. Okay, it has the potentiality to cause harm to the human beings and to the environment. And so we have the following immediate hazardous effects of earthquakes. The first one is ground shaking. That explanation is not needed. Ground shaking, that is shaking and trembling of the ground. So this is immediate effect. Then differential ground settlements. Okay, differential ground settlement means disposition of the ground. Okay, ground settlement means disposition of matters, ground, that is ground settlement. Then lane and the mudslides. Okay, lane and the mudslides. Landslide may be taken place when there is earthquake and the mud may be flowing down. Okay, mudslide may be there. Then soil liquefaction. Soil liquefaction means because of the tremor, okay, solid soils may be converted to liquid. So this is occurred when the soil is filled with water and the major component of the soil is clay. Okay, when there is hacking and trembling, then the solid soil may be turned into liquid, that is soil liquefaction. Then we have ground lurching. Ground lurching means move abruptly, suddenly. Okay, unable to control. Then avalanches. Avalanche, you know, that is a sliding of the mass of snow. Okay, snow and ice. Sliding of the snow and ice in the mountainous area, that is avalanche. It is just like landslide. Okay, that is the sliding of the snow and ice. Then ground displacement, that is occurred when there is faulting process. Then there may be flood from dams and levee failures. Because of the earthquake, dams may be broken. Then levee may be broken. Okay, levee, you know, levee, see, this embankment. Okay, embankment. So this is the river. Okay, see, this is the river, and here this is levee, and this section may be broken, and there may be flood, and then fire. So whenever there is earthquake, somebody may be cooking and the building may be collapsed, and from that fire may break out. Then structural collapse. means collapse of the railway line, buildings, flyover, bridges, okay, structural collapse. Then falling of objects. So when we are inside the buildings, then objects, ceiling fans, then other objects attached on the wall and ceiling may be falling on us, okay, may hit us, causing injury. And next we have the tsunami. And because of the earthquake, big waves, sea waves may be rising, and that also causes killing of the human beings and destruction of the structure. So we may be learning about tsunamis in detail after some minutes, okay. So let us read. The first 6 listed above have some bearings upon landforms. Say Roman number 1 to 6. Roman number 1 to Roman number 6 is related with the landforms, okay, that is effects of earthquakes on the landforms. Then while the others may be considered the effects causing immediate concern to life and properties of people. Then from 7 to 12 it is related with the destruction of the life and the properties, okay. And the effect of tsunami would occur only if epicenter of the tremor is below the oceanic waters and the magnitude of the wave is sufficiently high. And tsunamis, you know, these are the waves generated by tremors and not by earthquake itself. So here we have this, okay, this is how tsunami these are occur. See, when there is earthquakes, okay, on the bed of the sea, that is below the sea. See here, earthquake is occurred here, okay, below the sea, and here on the seabed we have the epicenter, and from the epicenter these earthquake waves are propagated, and when it reaches here, then waves, big sea waves arises. And see here, the magnitude of the sea wave increases, okay, as the distance increases. See here, from here the size of the wave is small, but as the passes, as the distance is increased, then the amplitude or the magnitude of the wave is increased. And see here, when it reaches the land, here the wave height is big, okay. And because of this, destruction of the structures and the loss of life is occurred. See here, this is the tsunami wave, big wave, and it is hitting here, okay. So it is, tsunamis are big waves which are generated by the earthquakes, okay, occurred below the seabed. You have to know. And next, see, we have these some photographs, okay, about the these effects of earthquake. So this is about collapse of structure, okay, flyover bridges are collapsed. Then this is about soil liquefaction. See here, the left side, this is soil liquefaction. And here this is also collapse of building. Then this is collapse of, again, these buildings, structures. This is landslide caused by the earthquake, okay. So this is displacement of the ground, okay, this ground settlement. This is another photograph of soil liquefaction. And so this is scene of a tsunami causing destruction on the sea coast. This is another scene of tsunami, okay. So these are some photographs showing these effects of earthquakes. And you must know that, see, earthquakes activity lasts for only few seconds, but its effects are devastating, provided the magnitude of the earthquake is more than 5 on the Richter scale. Okay, if the magnitude of the earthquake is more than 5, on the Richter scale, then it is devastating. And as I told you, if Richter scale has increased to 6, that is from 5 to 6, so we have got a difference of 1 magnitude. So a difference of 1 magnitude means 30 times, 30 times 4, 30 times increase in the strength. And so these are the photographs given in your book about the these effects of earthquakes. And now let us see this frequency of the earthquake occurrences. Means the number of earthquakes occurring in a year. See, as we learned, earthquake is a natural hazard. If a tremor of high magnitude takes place, it can cause heavy damage to life and property of people. If an earthquake of high magnitude, say more than 6, 7, 8, takes place, then it can cause heavy damage to life and property of people. And however, not all parts of the globe necessarily experience major earthquakes, major shocks. We experience these major earthquakes only in few places on earth, not everywhere. Not all parts of the globe necessarily experience major shocks, major earthquakes. And see here, you must know that earthquakes of high magnitude, that is 8 plus, magnitude 8 plus, that is Richter scale 8 plus, are quite rare. Earthquakes of high magnitude, that is 8 on the Richter scale or more than 8 on the Richter scale, are very, very rare. And they occur once in 1 or 2 years. Earthquakes of this Richter scale 8 plus occurs only once in 1 or 2 years, whereas those of tiny type, that is the earthquake of Richter scale 1, 2, 3, tiny types of earthquake occur almost every minute. Every minute there is earthquake. Every second we have earthquake in the earth interior. But the Richter scale, magnitude is very, very small that we don't feel it. As I told you, magnitude of 1, 2, we don't feel it. But it is recorded in the seismograph. It cannot be recognized. It cannot be felt by the human beings, but it is recorded in the seismograph. These smaller earthquakes. So this is about frequency of the earthquake occurrences. Now do you have questions regarding this frequency of earthquakes, types of earthquakes, or about the Richter scale, about the Mercalli scale? Do you have questions? Yes, boys and girls. Are you connected? Do you hear me?
So what is Mercalli scale?
Mercalli scale, actually this is a scale to measure to measure the intensity of the earthquake, how strong the earthquake is. Mercalli scale is the scale which is used to measure the intensity of the earthquake. How much the earthquake has destructed or can destroy the surface of the earth or these human beings. And this Mercalli scale takes into account only the visible damage caused by the earthquake. How much the earthquake has damaged the surface of the earth and the structures built by the human beings. And for the Mercalli scale, the intensity scale is ranging between 1 to 12. As I told you, Mercalli scale 1 means we don't feel we don't feel the tremor. Okay, Mercalli scale 1 means human beings do not feel the tremor, and Mercalli scale 2 means if a person is at rest, if he is taking rest, if he is sitting quietly, so he may feel it. That is Mercalli scale 2. But the same, if we are walking, we may not feel it. Okay, the person at rest may feel the tremor, but if we are walking or if we are driving, then we may not feel it. That is called Mercalli scale 2. And the Mercalli scale 12 means this is the maximum. See, the surface of the earth may be just moving just like these water waves. Okay, so large rock masses may be displaced, then objects on the ground may be thrown into the air. In this case, you may see that the ground is just rolling, just like a sea wave. That is called Mercalli scale 12. Okay, so Mercalli scale means it is a measure it is a scale to measure the intensity of the earthquake. Okay, Mercalli scale means
Yes, sir.
it is a scale to measure the intensity of the shock of the earthquake, how strong the earthquake is, based on the visible damage. Okay, any other question?
No, sir.
Okay, then let us stop here for today. And do not forget to send your names in the WhatsApp group for attendance. Thank you very much for joining my class.